The SocIoTal access control system is designed as a combination of different authorization technologies and tools in order to enable a suitable authorization solution for IoT environments. The basic SocIoTal authorization scenario consists of four main entities: the capability manager as a CoAP-DTLS server accepting requests for capability tokens generation, the policy decision point over PDP as an HTTP server based on XACML accepting authorization requests from the capability manager before generating a capability token, and the PDP uses a set of access control policies that are obtained from the policy administration point or PAP as a point in which users can define their access control preferences for their smart objects. Moreover, the capability client, which is intended to make a request to the capability manager to obtain tokens in order to get access to other IoT devices, and the capability evaluator as a CoAP-DTLS server receiving access requests from capability clients containing the tokens previously obtained. In the demo scenario for authorization, Bob tries to get access to a resource on a device of Alice. Firstly, according to the main entities of the SocIoTal access control system, Alice is able to define her access control preferences over her resources through the PAP that will be evaluated by the PDP. This component is accessible via a web browser in this address. So in this case, Alice has defined a set of access control policies for some of her resources. We click on Manage Policies, and here we see she has specified 4 policies. Now if we click on the device 1 location policy, we see it has a rule called device 1 get location in the list of rules, and we see this rule specifies that for the location, these subjects, such as Bob, are authorized to get it. Now Alice installs the Capability Evaluator application on her smartphone, and she wants to provide information about her location only to authorized users. So she opens the application, and in this case she states in the service text field that she is going to provide her location that is detected by the smartphone in this case. So now she clicks on Start Service, and as we can see, the service provided in her location is listening at that IP address. Now Bob tries to get access to the location of Alice, and for this end he tries to get a capability token. By default, capability tokens that are obtained will be stored in the capability tokens folder of the client device. So we open the smartphone of Bob, and we see he has no capability tokens on that folder. On the right side, we see the capability manager and the PDP components are running, and now Bob opens the capability client application, and he tries to get the token to get access to the location that is provided by Alice's smartphone. So firstly, he specifies the IP address in which the location service of Alice is running, and he clicks on the Request Capability Token button, and this request is sent to the capability manager. This chain is CoAP-DTLS with certificate-based mutual authentication, and then the capability manager queries the PDP in order to know if the user is authorized, and consequently if a proper token must be generated for him. As Alice defined on the PAP that Bob is authorized to get her location, a new capability token is generated for him. Now if we go to the capability tokens folder, we see Bob obtain a token that can be used to get access to Alice's location. Finally, Bob, through the capability client application, tries to get access to the location of Alice. So he clicks on the Try Access button. The client application then tries a token for the action and resource being specified, and sends a request to the capability evaluator entity running at the Alice's smartphone. Then the capability evaluator verifies the token is valid and provides Alice's location to Bob.